Okay, before we get started, I'm going to let you have 3 seconds to read the terms and conditions. So hit pause, because if you continue to watch the information in this video, you are agreeing to the terms. The terms are simple. If you're a business, 10% of your earnings from any of this information is automatically to be paid to me monthly via cryptocurrency. And for individuals, it's freely given to you for private use, but if you sell, you're a business. I don't care if it's official or not. If you sold it and you made money off it, you're a business. The same terms apply to you. Other than that, what I'm trying to hopefully accomplish is the engagement of the thought of how would we create free energy, and is it possible? I know physically it's not, but you know, how could you do it or get very close, at least like 99% efficient? And that's what the information in this video is going to demonstrate. If you're not willing to accept these terms, do not continue with this video. This video is off limits to you. It's only for people who agree to the terms, period. All information inside of this video is reserved to the creator. If you use my information, you must credit me with your works, and if you're a business, you must yield 10% of your earnings from the usage of this information and all profits made from it. With that said, let's go ahead and start. Okay, so this is it. Very simple circuit design. I am on circuitlab.com. You can go and try it yourself. I'm doing a time domain sweep. And because they require you to have an input in order for it to run, and I'll show you it running without one, I put a 1-volt battery on the left side to act as a surface induction. In the real-time simulation, I actually use 1 microvolt that's in each one of these farad capacitors. So it's already pre-stored on the line, and 0.1 U-volts here. But so I'm going to show you this working. Again, it's on circuitlab.com, and I'm going to run the time domain simulation. It is running, and while it's running, I'm going to go to another tab and show you the same circuit, a little different, but basically the same, except for over here where the battery was, I have a lamp and a bunch of resistors on the side. So what I'm going to do is only have one resistor on this circuit, which is 333 ohm, and I have one let me go ahead and reset. 1 microvolt into each capacitor with theta volt inside of the far right capacitor. So this screen right here is that capacitor up here. This is the capacitor down here, and this is that capacitor. Okay, so before we go any further, just know that that's the design, which is a slight variation of that design, but basically the same. The simulator is still running at 19%, and that's to confirm 2 separate different simulators, so you can't say there's something wrong with the simulator. So with that said, I'm going to hit run, let it start. We're going to watch this time down here. It's going to be about 2.5 seconds, between 1.5 and 2.5 seconds. You're going to see something, and when you do, you're going to say that is absolutely impossible. Still running. Now, the whole nature of free energy is that it would spontaneously start by itself. Like, that's the whole thing. If it's free, truly free, it should just come out of nowhere for no reason. And this circuit is demonstrating right now that that is actually possible. The mathematics is sound. It follows all the standard laws of electrical engineering, except in physics we would probably have some issues. But we're going to go ahead and stabilize this. And the way we stabilized the voltage creation was through ground. Right? We just turned on 2 switches. That is 1,120 plus gigavolts. That is 500 plus gigavolts. That is 7.8 kilovolts. That is 0 volts on a lamp, 0 volts on the ground. But watch what happens. When we put a load on it, those gigavolts turn to very stable and start climbing. And the lamp pretty much blew up, but we'll not worry about that part yet. So that is one simulator saying that it is possible. If I go to the second simulator, which apparently stops, you know, going through the percentages if I'm not on there, so I'll leave it on. We're going to look at this diagram. The only thing this diagram doesn't have is the resistors on the right side and the lamp on the left side, which allowed me to basically stabilize the current and induce more current through the draw. Instead, we replaced it with a 1-volt battery. This is a simple 1-volt battery. If what I did was correct and it was not a simulated problem, we should get the same results, right, off of 2 simulators. Give me a second. It looks like it's about 90% complete. And it is now plotting, as it says, transient solver done for that amount of time. And what is this? A 1-volt input, 1.5 way over here, turns into kilovolts, 10.19, and then magnifies itself, turns into more kilovolts, 85, and we're going to assume that that's going to continue onward. Please share this video and make sure that you do the Coinbase referral in the link below, because that's the only way I get my donations. It doesn't cost you anything. All you got to do is take some time, set up a Coinbase account, and maybe send some donations my way. But I hope this helps with your experiments, and it looks like at least 2 simulators say the exact same thing. Alright, have a good day. God bless.